Beneath one of Europe's most beloved coastlines, something is stirring that most people scrolling through their newsfeed have never even heard of. It isn't Vesuvius, the volcano everyone points to when they think of Italian disaster. It's a much older, much larger, and arguably far more dangerous system sitting directly underneath 500,000 people, and in the last few weeks, it has been shaking harder than it has in living memory. This is Campi Flegrei, the Phlegraean Fields, a sprawling volcanic caldera just west of Naples. Unlike Vesuvius, which rises as a single, recognizable cone, Campi Flegrei doesn't look like a volcano at all. It's a wide, gently rolling depression, roughly 12 to 13 kilometers across, dotted with craters, hot springs, and steaming vents, with a large portion of it submerged beneath the Gulf of Pozzuoli. The system erupts trachytic, to phonolytic magmas and explosive plinian to phreato-magmatic styles, producing pyroclastic deposits, domes, and maars, and persistent fumarolic activity at Solfatara and Picciarelli, along with hot springs, reflect a vigorous hydrothermal system fed by shallow magma. Because the ground itself is the crater rim, and because a modern city has been built directly on top of it, most residents live their entire lives without registering that they are standing inside one of the most studied supervolcanoes on Earth. To understand why scientists are watching this place so closely right now, you have to go back tens of thousands of years. Campi Flegrei has produced two eruptions of almost unimaginable scale in its geological past. The larger of the two, often called the Campanian Ignimbrite eruption, occurred around 40,000 years ago and is considered one of the most powerful volcanic events in Europe over the last 200,000 years, an eruption so large it likely altered regional climate and blanketed a huge area in ash. The soil of the Campanian plain today is rich and fertile precisely because it is made of broken down volcanic ash from that eruption. A second major eruption, the Neapolitan Yellow Tuff event, followed roughly 15,000 years ago and helped shape the caldera structure that defines the region today. These are the events that earn Campi Flegrei its supervolcano label, not because it is guaranteed to repeat them, but because the underlying system has demonstrated it is capable of them. Since those ancient cataclysms, the caldera has erupted many more times at smaller scales, and the most recent confirmed eruption happened in 1538, when a new hill, Monte Nuovo, rose out of the ground over the course of about a week. According to historical accounts, a swarm of earthquakes had troubled the inhabitants of Pozzuoli and Naples all summer long, and on the eve of St. Michael's feast in September of that year, a very large earthquake was followed immediately by a sound like the thunder of heavy artillery, marking the start of the eruption. That event has remained the only eruption of Campi Flegrei in almost 4,000 years, and it was followed by 430 years of relative quiet. That quiet didn't last forever. Signs of renewed activity were first recognized in the late 1960s, and since then, the center of the caldera has risen by as much as 3 meters, with several hundred earthquakes felt by residents between 1983 and 1984 alone, damage severe enough that thousands of people in Pozzuoli had to be evacuated. That crisis eventually calmed down, and for a while it looked as though the volcano had settled back into dormancy. It hadn't. Around 2005, a new phase of unrest began, and unlike the episodic crises of the 20th century, this one has not stopped. It has been slowly, steadily building for 2 decades. The core phenomenon driving all of this is something called bradyseism, a term that describes the slow rise and fall of the ground as magmatic gases and hydrothermal fluids move beneath the surface. Since the current unrest began, the ground near Pozzuoli has risen by approximately 1.4 meters, accompanied by earthquakes of increasing intensity. That may sound modest, but picture an entire coastal town, its harbor, its streets, its building foundations, being pushed upward centimeter by centimeter year after year by pressure building somewhere below. The uplift has not been smooth or constant. It has accelerated particularly since around 2018 when the earthquake activity intensified, in a way researchers hadn't quite seen before. The scale of that acceleration only became fully visible recently when scientists applied new tools to the problem. A team from Stanford University, working with Italy's National Institute of Geophysics and Volcanology, INGV, built an AI-based detection model and reprocessed years of seismic data. The new approach more than quadrupled the number of earthquakes detected and data recorded in the caldera since 2022, revealing thousands of small tremors that older monitoring systems had simply missed. When that enhanced dataset was published in the journal Science, the numbers were striking. Researchers analyzed nearly 50,000 earthquakes that occurred in the Campi Flegrei caldera since 2022, most of them too small to be felt by the millions of people living nearby. But their maps revealed exactly where seismic activity has been accelerating, concentrated along shallow fault lines in urban zones and around the caldera's ring structure. In other words, this isn't rumor or exaggeration. This is measured, peer-reviewed, published science, and it shows a system that has been quietly ramping up in the background for years. Importantly, the same researchers were careful about what this activity does and doesn't mean. Despite the dramatic increase in detected earthquakes, scientists emphasize that there is no direct evidence of magma actively moving toward the surface. The unrest appears to be driven largely by pressure and fluid movement within the hydrothermal system layered above a deeper magma source, rather than magma itself, forcing its way upward. That distinction matters enormously because it separates two very different kinds of risk. The risk of damaging shallow earthquakes and ground deformation, which is already real and already affecting people's homes, and the risk of an actual eruption, which remains uncertain and is being watched extremely closely rather than treated as imminent. Then came the summer of 2026, and the unrest stopped being an abstract scientific story and became something residents felt directly under their feet. On July 31st, at 7:46 in the evening local time, a magnitude 4.7 earthquake struck near Naples with its epicenter close to the Solfatara crater in Idu, Pozzuoli, at a depth of only around 3 kilometers. It was the strongest tremor recorded there in 40 years, felt strongly across Naples and its surrounding area, as well as on the islands of Precede and Ischia. A second aftershock of magnitude 3.8 followed a couple of hours later in the Gulf of Pozzuoli, part of a swarm of more than 30 tremors recorded through that single evening, with additional shocks reaching up to magnitude 3.1. Italian civil protection officials confirmed it was the strongest earthquake recorded in the area since continuous instrumental monitoring began, surpassing 2 earlier tremors of magnitude 4.6 that had occurred in 2025. The human cost of that night was immediate and visible. At least 26 people were injured, several unoccupied buildings collapsed, and part of a coastal cliff crumbled. Many residents chose to spend the night outdoors, a precaution taken because large aftershocks are statistically most likely in the hours and days immediately following a strong quake. Train services and port operations in the area were disrupted as authorities carried out safety checks. INGV confirmed at least 10 aftershocks following the main event, and the pattern fit into a broader trend, since the 2025 magnitude 4.6 quake had itself been described as the strongest in 40 years at the time, only for the 2026 event to break that record within roughly a year. That kind of repeated record-breaking is exactly the sort of trend that seismologists pay close attention to, because it suggests not a single isolated event, but a system whose baseline activity is genuinely shifting upward. In the weeks since that quake, the ground has not gone still. Smaller earthquakes have continued on a near-daily basis, the background hum of a caldera under sustained stress. In the 7 days leading up to August 19, 2026, the area recorded dozens of small quakes, including a magnitude 1.1 event just southwest of Pozzuoli, and over the previous month, the strongest shock had reached magnitude 4.5, centered about 8.7 kilometers west of Naples. These smaller tremors rarely make international headlines on their own. Individually, a magnitude 1 earthquake is not dangerous, but taken together, as part of a pattern that has now been building for 2 decades and sharply accelerating over the past few years, they form a picture that Italian scientists describe with a very specific, carefully chosen word, unrest. So what is actually happening underground to cause all of this? Researchers have been trying to answer that question with increasingly sophisticated tools. A team, using data from the German Research Center for Geosciences, identified previously unrecognized seismic signals beneath the caldera, very long period signals, or VLPs, that hadn't been documented at Campi Flegrei before. These signals point to a fissure-like structure at a depth of around 3.5 kilometers, and researchers interpret them as the resonance of one or more fluid-filled crack-like structures connecting a deeper deformation source with the fumarole fields at the surface. Put simply, there appears to be a network of cracks acting almost like plumbing, channeling heat, gas, and fluid from deep magmatic sources up toward the vents, where residents can see and smell the sulfurous steam escaping every day. A separate and, frankly, more sobering line of research is focused not on where the fluid is moving, but on what all this repeated stress is doing to the rock itself. A 2023 study published in Communications Earth and Environment analyzed ground deformation and seismicity data going back to 1984 and reached a conclusion that deserves to be stated plainly. The unrest at Campi Flegrei is consistent with the start of rupturing below the surface, and the ongoing activity has been changing the structure of the caldera's crust over time. The researchers found that this kind of rupture tends to be preceded by repeatable variations in the rate of seismicity alongside ground movement, which trace how much accumulated stress is being released through local earthquakes. That paper's predictions have, according to more recent analysis, continued to hold up as new data has come in. Building on that work, a 2026 study made headlines in the scientific press for a specific and unsettling finding. Since 2005, the floor of the caldera has risen about 1.4 meters, possibly indicating the movement of volcanic gases below the surface. And the new research suggests that this increased activity has reached a point where even its rate of acceleration is itself accelerating, indicating that something is likely to change soon. The study's lead author was careful to draw a hard line around what the data can and cannot tell us. The research can identify when the system is likely to reach a breaking point, but it cannot determine what will actually happen once that point is reached. That is the honest, current state of the science, a system under mounting strain, approaching some kind of threshold, with genuine scientific uncertainty about whether that threshold leads to a small, localized eruption, a period of subsidence with no eruption at all, or something larger. It's worth pausing here to separate established fact from open question, because this is exactly where sensational headlines tend to blur the line. What is established? The ground is rising, the earthquake rate has increased substantially since 2018, and again through 2025 and 2026. The crust is showing measurable signs of structural change consistent with ongoing rupture processes, and the July 2026 quake was the strongest instrumentally recorded event in the area's history. What remains genuinely uncertain and is actively debated among volcanologists is whether any of this unrest will culminate in an eruption, when that might happen, and how large such an eruption could be. Multiple experts, including volcanologist Christopher Kilburn at University College London, have pointed out that should an eruption eventually occur, it is far more likely to be small and localized, similar in scale to the 1538 event, rather than anything approaching the ancient supereruptions of 40,000 or 15,000 years ago. There is no scientific consensus predicting an imminent catastrophic eruption, and no credible monitoring agency has issued warnings of that kind. That distinction matters enormously for the roughly 500,000 people who live inside what Italian authorities designate the red zone, the area considered at highest risk in the event of renewed volcanic activity. There are 15 towns within the Campi Flegrei area with a combined population of more than 500,000 people living in this red zone, and 2 years ago the Italian government announced updated emergency measures in light of the increased seismic activity, revising evacuation plans to prepare for a possible mass evacuation. This is not a population living in ignorance of the risk. Italian civil protection authorities run regular drills, monitoring stations operate around the clock, and INGV publishes weekly bulletins tracking seismicity, deformation rates, and gas emissions in exhaustive technical detail. If anything, Campi Flegrei is one of the most intensively monitored volcanic systems on the entire planet, precisely because of how many people live directly on top of it. That brings up an important point about the idea that the media has stayed silent on all of this. It hasn't, not in any meaningful sense. Italian newspapers covered the July earthquake extensively. INGV's technical bulletins are public and updated regularly, and outlets ranging from Reuters to Live Science to nature-affiliated journals have reported on the scientific findings as they've been published. What's true is that a single earthquake swarm in southern Italy doesn't dominate a global news cycle for more than a day or two, especially once the immediate aftermath passes and no eruption follows. Algorithmic news feeds tend to reward breaking, dramatic moments rather than a slow-building geological story that unfolds over years. That's less a conspiracy and more a structural feature of how modern news attention works, which is exactly why independent, well-sourced explainers matter, because they can give a story like this the sustained context that a single day's headline cannot. There's also a comparison worth making, because people often assume Vesuvius, looming visibly over Naples, is the region's primary threat. Vesuvius is genuinely dangerous, and roughly 3 million people live within range of its potential hazard zone. But many volcanologists consider Campi Flegrei the more concerning long-term risk for a specific structural reason. Vesuvius is a stratovolcano with a single well-understood conduit system. Campi Flegrei is a caldera, a collapsed volcanic system with multiple vents, a shallow and widespread magma reservoir, and a documented history of producing eruptions from unpredictable locations across a 12-kilometer wide area. That unpredictability, combined with the fact that the caldera sits directly beneath dense urban development, including parts of Naples itself, is what keeps scientists monitoring it with such intensity. Not all of the recent research is grim, and this part of the story deserves just as much attention as the warnings. A study published in the journal Science Advances, alongside earlier 2023 work published in Geology, examined the role that carbon dioxide and groundwater play in driving the caldera's seismic swarms. Researchers, including Grazia De Landro at the University of Naples, Federico II, working with colleagues at Stanford, compared data from the 1982 to 1984 crisis with data from the 2011 to 2024 Unrest period, and found something genuinely useful. The characteristic land uplift and burst-like shaking, accompanied by the rumbling sounds that have become a signature feature for residents, appear to signal steam-driven explosions triggered when liquid water rapidly flashes to steam during fracturing caused by earthquakes. Their analysis suggests that this cycle of unrest could potentially be reduced by managing groundwater levels or controlling the flow of water into the reservoir located beneath Pozzuoli. In practical terms, that means the volcano's most disruptive current behavior, the swarms, the shaking, the ground movement damaging buildings, might not be an unstoppable force of nature, but a hydrothermal pressure system that engineers could, in theory, learn to manage. That doesn't eliminate the deeper magmatic risk, but it offers something rare in this field, a concrete, testable path toward reducing harm to the people living above it, rather than simply waiting and hoping. None of this changes the reality on the ground this week. As of the past few days, seismic stations around Pozzuoli have continued to register frequent small tremors, part of the ongoing background activity that has become routine for residents but remains anything but routine for the scientists tracking it. The overall alert level set by Italian authorities remains at yellow, signifying unrest that requires close monitoring but falls short of predicting an imminent eruption. That classification could change, and INGV's bulletins are updated regularly precisely so that any meaningful shift gets caught quickly. What makes Campi Flegrei such a compelling and important story isn't that it's hiding some secret truth the world refuses to acknowledge. It's that it represents one of the clearest real-world examples we have of scientists trying to forecast a genuinely uncertain natural hazard in real time, with modern tools, while hundreds of thousands of ordinary people go about their daily lives, directly above the source of that uncertainty. Every earthquake swarm, every centimeter of uplift, every new AI-processed dataset adds another data point to a puzzle that remains, honestly, unsolved. Scientists can now say with confidence that the system is under increasing strain and behaving differently than it did even a decade ago. What they still cannot say, and what nobody honestly can, is exactly when or how that strain will resolve. Beneath one of Europe's most beloved coastlines, something is stirring that most people scrolling through their newsfeed have never even heard of. It isn't Vesuvius, the volcano everyone points to when they think of Italian disaster. It's a much older, much larger system, sitting directly underneath 500,000 people, and in recent weeks, it has been shaking harder than it has in living memory. This is Campi Flegrei, the Phlegreian Fields, a sprawling volcanic caldera just west of Naples. Unlike Vesuvius, it doesn't look like a volcano at all. It's a wide depression, roughly 12 kilometers across, dotted with craters, hot springs, and steaming vents, much of it submerged beneath the Gulf of Pozzuoli. The system erupts explosive Plinian to phreatomagmatic styles and persistence. Fumarolic activity at Solfatara and Picciarelli reflects a vigorous hydrothermal system fed by shallow magma. Because the ground itself is the crater, a modern city has been built directly on top of it, and most residents live their lives without registering they're standing inside one of the most studied supervolcanoes on Earth. Campi Flegrei has produced two eruptions of almost unimaginable scale in its past, around 40,000 and 15,000 years ago. Events so large they helped shape the Campanian plain and its fertile volcanic soil. Since then, it has erupted many more times at smaller scales, most recently in 1538, when the Hill Monte Nuovo rose from the ground in about a week. A summer-long earthquake swarm preceded that eruption, and it remained the caldera's only eruption in almost 4,000 years, followed by 430 years of quiet. That quiet ended decades ago. Renewed activity was first recognized in the late 1960s, and the caldera center has since risen as much as 3 meters, with hundreds of earthquakes felt between 1983 and 1984 alone, severe enough to force thousands of evacuations in Pozzuoli. A new phase of unrest began around 2005, and unlike earlier crises, has never fully stopped. It has been steadily building for 2 decades through a process called bradyseism, the slow rise and fall of ground driven by magmatic gas and hydrothermal fluid movement. Since 2005, the ground near Pozzuoli has risen by roughly 1.4 meters, accompanied by earthquakes of increasing intensity. That acceleration became clearer once Stanford researchers and INGV applied a new AI detection model to years of seismic data. The approach more than quadrupled the number of earthquakes detected since 2022. Researchers ultimately analyzed nearly 50,000 earthquakes in the caldera since 2022, mapping exactly where activity has accelerated along shallow faults in urban zones. Yet scientists emphasize there is no direct evidence of magma actively moving toward the surface. The unrest appears driven largely by pressure within the hydrothermal system, rather than magma forcing its way up, a crucial distinction between damaging earthquakes and an actual eruption. That distinction stopped being abstract this summer. On July 31st, 2026, at 7:46 p.m., a magnitude 4.7 earthquake struck near Pozzuoli's Solfatara crater. It was the strongest tremor recorded there in 40 years, felt across Naples and on the islands of precede and Ischia. A magnitude 3.8 aftershock followed, part of a swarm of more. Then 30 tremors that evening, and officials confirmed it was the strongest quake since continuous monitoring began, surpassing 2025's magnitude 4.6 events. At least 26 people were injured, buildings collapsed, and part of a cliff crumbled, with many residents sleeping outdoors afterward as a precaution. Smaller quakes have continued almost daily since. The week leading to August 19th alone recorded dozens of tremors, with the past month's strongest reaching magnitude 4.5. Individually harmless, together they form a pattern Italian scientists call Unrest. Researchers using data from Germany's GFZ identified previously undocumented seismic signals suggesting a fissure-like structure around 3.5 kilometers deep, interpreted as fluid-filled cracks connecting a deeper source to the surface fumaroles. More striking still, a 2023 study found the unrest is consistent with the start of rupturing below the surface, changing the structure of the caldera's crust over time, while newer 2026 research found the rate of acceleration is itself accelerating, indicating something is likely to change soon, though the same researchers stressed they can identify when the system nears a breaking point, not what happens once it's reached. What's established? Rising ground, sharply increased seismicity, structural crustal change, and a historic earthquake. What remains genuinely uncertain and debated among volcanologists is whether any eruption follows and how large it might be. Experts like UCL's Christopher Kilburn note that should one occur, it would likely resemble a small 1538 event rather than the ancient super-eruptions. More than 500,000 people live across 15 towns in the designated red zone, and Italian authorities have updated mass evacuation plans accordingly. Far from being ignored, Campi Flegrei is one of the most intensively monitored volcanic systems on Earth, tracked weekly by INGV. Even encouragingly, research suggests the caldera's disruptive shaking may stem from steam-driven explosions tied to groundwater, meaning managing water flow into the reservoir beneath Pozzuoli could reduce future unrest. The alert level remains yellow, serious, closely watched, but not predicting imminent eruption. What makes this story compelling isn't hidden truth or silence. It's honest scientific uncertainty, playing out in real time beneath hundreds of thousands of lives. That uncertainty is uncomfortable, but it's also the truth, and it's a far more interesting story than any manufactured claim of silence or cover-up. The real story here is one of careful, ongoing science trying to keep pace with a restless piece of the Earth, and of a densely populated region learning to live with genuine, quantifiable risk, while researchers race to understand it better. If you found this deep dive into one of Europe's most closely watched volcanic systems valuable, make sure to subscribe so you don't miss the next update as new data comes in. Hit like if you want more clear, fact-checked breakdowns of stories like this, and drop a comment letting me know what other geological or scientific mysteries you'd like covered next.